Hello all, this is Mr. G, and after this lesson we should be able to find the domain and range of a function when given a graph. Find the domain and range of a function when given a graph. This is a really critical skill, not just for algebra, but also for pre-calc calculus. Students who are prepared for those higher level math courses, one of the key things you need to be able to do is look at a graph and figure out, okay, what's the domain of this function? What's the range of this function? So let's make sure we remember what those words actually mean. The domain values are the x values of the function. They're the x values. Another way we can think of that is we can think of them as the input, the numbers that we're putting into the function. The range is just the opposite. The range are the y values, and rather than being the input values, they're the output. They're the numbers that the function sort of spits out based on the numbers we put in. So based on the domain values we give the function, it will give us different range values, depending on the type of function we're talking about. Let's take a look at the first one. So we've got a graph here. We got to find the domain and the range of the function. So we'll put a D here for domain and R here for range. That's probably enough space for the answers. Now remember, let's start with the domain. And remember, those are the x values. So we're talking about these values right there. On the x-axis. We got x equals 1, 2, 3, x equals 0, negative 1, negative 1, negative 1, negative 2, negative 3. Those are the values we're looking at. Now, for me, what made the most sense when I was learning this is whenever I saw a function, I said, okay, let me find one domain value that works and one domain value that doesn't work, meaning one domain value that will hit the function and one domain value that will not hit the function. So I want you to try that right now on your own. So look at these blue x values and think, okay, which ones will hit the function and which ones won't. Find one of each. We're going over the answers in 3, 2, 1, let's go. Well, there's lots of different possible answers. One that does work would be this one right here. That x value works because if we go up from it, it hits the function. So that x value, what is that? That's x equals 7. X equals 7 will be a part of our domain. Let's find another one. Or rather, let's find one that doesn't work now. I think that'll probably be more helpful. So x equals 1, x equals 7 is okay. One that will not work would be like x equals 3. Because if we look at x equals 3, no matter how far up or down we go from x equals 3, we never hit the function. So x equals 3 is not a part of the domain. So now that we sort of have a handle on, okay, what does it mean for a domain value to work on a graph and not work for the graph of a function, now it's time to actually describe all the values that are in this domain. And to do that, we sort of need to find the first domain value that works, or when it starts working, I should say. And that's actually right here. This value of x equals 1 is our first domain value because that's the first x value that actually hits the function. And then every x value after that, you can keep on going forever, will always hit the function. Remember, that arrow means it keeps on going. So what that means as far as our description goes is our domain is going to be all real numbers. So I'll say all reals where x is greater than or equal to, what was it, 1? Yeah, where x is greater than or equal to 1. Now, if we wanted to write that in what's called set notation, we could write it like this. Bracket 1, comma, infinity, close the parentheses. Now, what this essentially means is exactly what we have written above it. This means, okay, from 1 to infinity. From 1, and we keep on going higher and higher and higher, and we never stop. Now, this bracket, in case you've never seen this notation before, that just means or equal to. So that means we're starting at 1, and 1 is a part of the set. 1 is included. It's included. And we can't put a bracket on this side because infinity isn't a number. We know infinity just means we keep on going, we keep on going. We can always add 1 and get to a higher number. So we'd never have a bracket around infinity. All right, now let's talk about the range. So now we're switching gears. We're talking about the y values. So now instead of looking at the x-axis, we're looking at the y-axis, and I ask myself the same question. Okay, let me find one range value that works for the function, that will hit the function, and one range value that will not hit the function. So again, pause the video, look for those answers, then we'll go over it together. 3, 2, 1, let's go. A range value that works, I would probably pick this one, which is what? 1, 2, 3, 4, y equals 5. Y equals 5, y equals 5 is a part of our domain. Excuse me, it's a part of the range. That was a bad bad mistake on my part. Let me repeat that. Y equals 5 will be part of the range of this function because that's a y value that hits the function. One that doesn't work would be y equals 0. This one right there. Because no matter how far left or right we go from y equals 0, it's never going to hit the function. So y equals 0 is not part of the range. Now it's time to actually describe all the range values. So to do that, we've got to find the first range value that works, and that's right here. Y equals 1 to y equals 3. And if we look, it's y equals 3, and I guess this might confuse some students, so let's be careful here. So let's keep going. So y equals 3 works, y equals 4, y equals 5, y equals 6 looks like it works, but what happens at y equals 7? It looks like it's not going to hit the function, but it actually will. I mean, it's going to be way out here in the distance, maybe, but eventually, since we've got an arrow right there, the function will continue to go right and up. So all of these y values in the positive direction, everything above y equals 3 will work for the range, even though they're not hitting it in our standard window of 10 by 10. All right, anyway, so the range would be all real numbers, where y is greater than or equal to 3. Greater than or equal to 3. If we wanted to write this in set notation, it would be from 3 to infinity, and the 3 is included. That's why there's a bracket there. And of course, it undoes everything. Oh well. So our domain was all real numbers where x is greater than or equal to 1. The range was all real numbers where y is greater than or equal to 3. Let's do a couple more together. Now we've got a v here, which hopefully we know means an absolute value function. We should remember that from algebra earlier. And we got to find the domain and the range. So the domain and the range. We're going to do the same thing. I'm going to ask myself the same two questions. Let me find one that works and one that doesn't work for each. Let's start with the domain. So we're talking about these values right there. The domain are the x values. Now, one that would work, let me see, x equals 8 would work, because if I go up from x equals 8, we can hit the function. One that doesn't work is a little bit more difficult to find. I might be tempted to say, oh, x equals 9, or excuse me, x equals negative 9 won't work, because if we go up, we're going to miss it. But we know that this arrow right there means it's going to continue going, and eventually that will be a part of the domain. So I don't see any domain values that will not work here. Every single x value will hit the function, and that's possible, so the domain is just all reals. All reals means every single number from as negative as we can go to as positive as we can go. And if we wanted to write that in set notation, that would be from negative infinity to positive infinity. Now remember, we never use any brackets with infinity or negative infinity. We only use open parentheses because the brackets mean we actually hit the number. And negative infinity and positive infinity, they're not actually numbers. They just mean we keep on going either in the positive direction or in the negative direction. Okay, now let's take a look at the range. So we switch gears. Instead of focusing on the x-axis, the x values, we focus on the y. So these are the values we're looking at, and we ask ourselves the same two questions. Let's find one range value that works and one range value that does not work. So a range value that works would be right here. What is that? Y equals 8. Because if we go to the left, we hit it. Anything to the right, we know we're eventually going to hit it because that line is going to keep on going. So y equals 8 is a part of the domain. Let's rewrite that. One that does not work, this one would not work. Because no matter how far left or right we go, we're never going to hit the function. And what is that? Negative 6? 1, 2, 3, 4, 5. Y equals negative 6. I forget if I highlighted negative 6 or negative 5, but it doesn't make a difference. Either of them will not be a part of the range because they don't hit the function. So we can't just say all reals here because we found a range value that does not work. So then the key is finding the first range value that works, and that's right here. That's right there, which is y equals negative 1. And all the range values above that will work because they're all going to hit the function somewhere. So what was that? Y equals negative 1. So the range will be all reals where y is greater than or equal to, was it negative 1? Negative 1. And if we wanted to write that in set notation, it's including negative 1, starting at negative 1, going to positive infinity. And there we go. The domain was all reals The range was all reals where y is greater than or equal to -1, written in sort of in a sentence form and in set notation. All right, just two more to go. Find the domain and the range of a function. Here we have a linear function. Got to find the domain and range. And I want you to try this one on your own. Pause the video right here, give this one a shot, and we'll go over the answers together in a second. 3, 2, 1, let's roll. The domain, looking at our x values, I don't see a single x value that will not hit the function. So the domain is just all reals. And in set notation, that would be from -infinity to +infinity. The range, now we're focusing on the y values. Similarly, I don't see a single y value that won't work. I mean, you might be tempted to say, like, what is this, -9? Because it looks like it doesn't hit the function, but we know this line is going to keep on going down. Eventually it'll hit. So the range is the same as the domain. It's all real numbers. So we can just say all reals. And if you want to write it in set notation, -infinity to +infinity. You don't need to write both of those. You can write either all reals, or you can put the set notation because they mean the exact same thing. I'm just showing you two different ways to write your answer. All right, let's do one more. And again, I want you to try this one on your own. Pause the video here, give this problem a shot, come back when you think you have an answer. 3, 2, 1, let's go. Finding the domain and finding the range. The domain, focusing on the x values, I don't see a single x value that will not work. So that means the domain is all reals. All reals, and again, I'll show it in set notation. You don't need to write both of these. Either one is completely fine. Either all reals or the set notation, -infinity to +infinity. Then for the range, we're focusing on the y values, and I do see y values that will not work. The first y value that will work is right there, which is y equals 3. That's going to be the first range value we have. And this is a little bit different. This is the first one where it's everything below everything below +3. So the range would be all reals where y is less than or equal to 3, because the range values are all below 3. Now, if we wanted to do this in set notation, we have to say from -infinity to +3, because 3 is the maximum range value. It's the maximum value of this function. So the domain was all reals. The range was all reals where y is less than or equal to +3. Hopefully this makes sense. If you have any questions, let me know. Enjoy the rest of your day.